Hey guys, welcome to Dozer Shop. I've been busy but not doing too much shop work lately, but I'm getting stuff done in my life. So I've been doing a lot of unboxing videos, always looking for good useful additions to the shop on eBay or otherwise. Got a cool one for you here. This is more the rigging related item. My friend Jim C. up in Grand Island, Buffalo, New York. I think he's 78, and he's really active. He's moving machines. He sold his Bullard vertical boring lathe, and he's got a horizontal boring mill that he sold well over 10,000 pounds. So he's been rigging stuff, and he keyed me in on a jack. Actually, he's up to 4 of these jacks. The name of this jack is Rees, not Reese, but R-E-E-S, Rees. And I think they're made around 1920. And they're quite old, but they're being from 1920, they're a mechanical jack. And what's cool about them is they are a toe jack, and all you machinery guys know that toe jacks are great for getting machines off the ground to move them and set them on skates or what have you. So this is a mechanical toe jack from the 1920s. Rees jacks were, I think, supplied with Pierce Arrow automobiles and maybe Pierce fire trucks. Don't know exactly if there's a relation there, but I know they were supplied with the heavy trucks of the day as a tire changing jack. Got some insulation foam, might use that again for something. Got some Armax foam, whatever, it's kind of small. Honeycomb. The box is well aligned with foam, so the seller did a great packing job. This is a cool jack. I'm going to pop her out here. Man, well, this bad boy, eh? Pretty good, hey? Looks to be in good condition. Ooh, it kind of spins on a high center. Ooh, it's a flat casting, but maybe we could do some machining on this thing. It's got a little wobble to it, that's fine. Toe jack. It's got a little ratchet mechanism. Looks like it needs a spring. Something there. Well, we can fix it. Get this box out of the way so I'm not tripping. Let me show you guys the handheldery version. Can shake the camera all around and get you all dizzy. Steady as she goes, like piloting a ship. Alright. You can kind of see Rees number 2A. R-E-E-S. No E. Oh, sorry, patents, da-da-da-da. So, the way I understand this works, so of course that's a ratchet, and that's down, it's up, and is that up? See here. Oh, that's going up. We'll have to figure out how the ratchet works. But there is the toe part, right? I should just keep it. Yeah, it needs a spring. But you can see it's coming up. And I want you to see the mechanism. So being a mechanical engineer, I thought this was a fascinating jack. And I'll explain it a little bit here. I bought this on eBay for $30 and paid just as much shipping, so it was about a $60 purchase here. You can see it's got a rack both sides of the lifting ram there, and the toe piece, of course, is coming up as well. That's pretty good clearance when you're in the ground. Now the deal is, there's a worm gear here, like a left-handed worm, a worm there, a left-handed one, and a right-handed one there, and they're on the input shaft, of course. So there's worm gears and worm wheels inside here that they mesh on. And next to the worm wheels is a spur gear. I think that's on this side, and it meshes somehow with the rack. So that's what it is. See the center line, if you get a good... So the worm wheels that they mesh on, and then spur gears attached to the worm wheels. And of course that lifts the jack ram there. You kind of see the shafts there, This thing's gonna probably get a good cleaning and take apart. But my buddy Jim said he likes it because, you know, unlike hydraulics, they could possibly leak. This thing, he can leave a machine jacked up for a day or two or whatever, infinitely really, because it's not going to slip back down. I don't have any Hillman rollers, but this is handy if you got like most of my machines, you can't see it, they're off the ground already. See that gap in there on steps, spacers. So you can see the sunlight highlighting my spacer. So that's just a piece of 1-inch bar stock I got. So I can run a pallet jack under it, and you might be able to see the Harding lathe is on 2x6 spacers, and it's either I got wheels on my press, as you can see. Everything is kind of on spacers, so I can move it with the pallet jack. But anyhow, for 30 bucks, really 60 bucks, I thought this jack was a good purchase. Old technology. Like I said, my friend Jim recommended this, and it seems like a jam-up jack, really. It's interesting. It's teetered. Either the ears are bent up or something. Doesn't matter much. I think it just needs a really good cleaning because this is full of gunge. I think it's missing a little spring of some sort, but that's super easy. Looks like a 5/8 bar would fit in there. Something like that, maybe. Is it tapered? I don't know. I'll bring you guys more on this, but I just thought you'd find it kind of cool. A Rees, R-E-E-S, jack from the 1920s, and it's a toe jack, and some of them are really cheap on eBay. Some are real expensive. There's one on eBay that says has the tag for a Pierce Arrow motor car, something company, something. The guy wants like $275 for it, but I got this for 30 bucks. Shipping was another 30. So if you guys are doing, machine moving and rigging and stuff, like I said, you know how indispensable a toe jack is, and that's exactly what this is. So my buddy Jim bought 4. I think maybe he's a little silly with the 4, but if you have a shop and you move stuff occasionally, jacks, let me pan over to my bars, right? Having moving bars and rigging supplies is indispensable, right? I got a couple bars here. Some are outside. I think this is an Ajax, right? Crookie bar, and it's a pointy tip on the end. And like I said, I got a couple of Klein bars, another Ajax bar. That bar, I guess they call it a clay bar or something, or a digging bar. I found that on the side of the road, and it's about 5.5 feet. But anyways, enough about that. Yeah, you can't. All right, we're talking about bars. I think this is my bar. you know, on the right I got the lady slipper bars. It's good to have a pair of lady slipper bars because then you can use two together and pry off a pulley or a hub or something. That orange bar, I bought that when I first moved into my new house for doing demolition, and then I got a flat bar in the house. And you know, whatever, hammers, but we could talk about tools forever. But I'm trying to keep this video short. Yeah, Rees jack, toe jack. We'll bring you more on this, but I thought you'd appreciate the unboxing and get a first look. And from an engineering point of view, with the opposing worms and the worm wheels and the spur gears on the rack, double-sided rack, how often do you see that? A cool design, right? Very cool. So, you know, thought I'd share that with you guys, and we'll bring you more on this a bit later. All right, guys. I took the Rees jack apart, and I'm cleaning it up, and I found the worm shaft here. Let me show you. So, this is the worm shaft I was telling you guys about. That's the input side. It's got double keyways pinched into it. It's kind of cool. But it's bent. I'm gonna kind of try to. It's bent in the center. It wobbles. It's bent right in the middle. So what I'm gonna do is I'm gonna try to show you guys. I'm gonna put on the press, and I'm going to press it straight. Now, I don't know if you can see the high point that I've spun it on the bed of the jig bore is where those two leads start. That's the high point of the bend. For whatever reason, that just seems to be the high point. So that's what I'm going to clock up near the press ram. So hope you can see it. We have here the mighty K.R. Wilson press. And one of the cool things the K.R. Wilson designed, aside from the rapid advance on the quill there, is these press plates are also super heavy duty V-blocks, right? So if you flip them upside down, they are a set of V-blocks. Awesome, right? Very cool. So, thought I'd film this and show you guys a little bit, you know, what this process is. I know you guys probably watch Keith Fenner and his shaft straightening videos, his marine shafting and whatever. So I am going to attempt to push this straight. Now I'm kind of seeing, should I favor my bend one way or the other? I don't know. I guess I'll start in the middle and see how it goes. Now this is a 100-year-old jack. I'm assuming it was built sometime in the 1920s, right? I'm going to put a spacer on that, but I'm just going to see where the high spot is. So it's 100 years old. Oh yeah. That is absolutely the high spot, right? Absolutely there. I'm going to take that up. So I'm going to press with like an aluminum something or other maybe. Here's an aluminum scrap of nothing here. Lock in the release valve, and I guess we'll see what happens. If I break it, you know, we are SOL here. I'm only up on like 1.5, 2 tons. It looks straight. I'm gonna overbend it. Oh yeah. I'm only at 1.75 tons. Maybe that did it. Don't know. I'm gonna take the block out, put the ram on there, and just twiddle it around. Oh geez. It's better. Needs more though. So, let me go up to 2 tons. Something happened. Ooh. That ain't too bad. Let me twiddle it. Seems I overbent it by maybe 30 thousandths. Okay. Bend it back. I don't know what that is there. I'm about 20 thousandths. Now I'm back at the high spot again. So, maybe I can tweak it with the hand leverage. Sometimes the hand lever is the way to go. See, I'm looking, the ram's kind of stationary and it's showing me my gap. Ain't much. Still at that original high spot. I'm showing about 10-ish thousandths. That's really good. I mean, that thing's maybe 5-ish. Still at the high, same spot. I don't want to overdo it. Still at that same high spot. I mean, it's within. I could tell you with the indicator. Maybe I should put the indicator on instead of guessing. Let me see if I got something real quickety quick. Of course I do. It's Doozer's shop. Alright. You get this blang changing thing here. Oh my God. You gotta be kidding me. So that's 0. -2, 0 plus nothing. 2.5. 1, 2.5. 0 is 0, 1, 2, 3. Not even 3. So plus or minus 1.5 would be 3. I mean, I'm not gonna mess with it, man. I think we're good. I mean, let me show you, because, you know, I'm gonna try and spin this here. Going to the minus there. I'd say we're absolutely within 3 thou of being straight, you know what I mean? And I gotta keep it in the middle here with my, you know, long ways. Now it's going. I'm not holding it as good as I was when I had the camera separate, but that's kind of how you do it. And that's my pressure gauge that I've been looking at, the old K.R. Wilson, Buffalo, New York, made in arcade. And the hand wheel, of course, what I was using is that. So that's pretty cool. I'll get you another shot when this is back together, but I'm telling you, this press makes it so easy to straighten things. And you know, that's the hydraulic engage, and then, you know, the pump lever if you don't hit your head on it. I got it set up pretty well. You know, I got tooling up for pushing and da-da-da-da. And down below I got my metal bins for, you know, steel storage. I'll give you guys another shot. I'll walk you over quite quick here. It's gross, it's nasty. It's in the parts washer. There's the ram. I got the gears soaking. And it's basically all it is. It's 2 gears. The ram, the body, and you know, the press, the worm gears. I'll bring it back when I get this thing put together there. Do the shop. Alright guys, back at the K.R. Wilson press, the mighty K.R. Wilson. Show you what I got happening here. This is the ram from the Rees jack, and like I said, it's a toe jack. I think some people call these foot jacks. I don't know, but this, I've always heard it called a toe jack, but either way. That's the top, and yeah, the reason I got on the press, as you might imagine, we got a bow to it. Because obviously you can see if the force is concentrated at the foot all the time, it's going to take a bend if they overloaded it. And I noticed, you know, this angle here is not quite 90 degrees. And I'm looking at it, and they got some sway back happening here. Not a lot, maybe a 1/16. But you can see I got a little aluminum block there, aluminum block on the end, halfway in the middle, and pressing where I believe the bend is. So let me set you up. All right, let me show you. I got the hydraulics locked in here. I'm gonna put some pressure on it. I'm gonna kneel down and watch. It's about 4 tons. It's going to have some spring. There, I seen an overbend there. Well, that's cool. How do I check it for flatness? A bent hacksaw blade? take to you. Looks a lot straighter than it was. It looks really good. This is milled square. The foot is still drooping, but I think maybe that's pretty good. Take you bird's eye here. The foot is still up in the air a little bit. Actually, it's the opposite way. So most of the rack is flat, and you can just see some daylight down there by the foot. And I think that's because it was bent and it was wearing there. So what I did under the rack is pretty much perfectly straight. Try to hold the camera so you can see it dead level there. But you can see some daylight under the foot. Now if you look, right, so that 4140 block is square, and this block is square, and you can just see a little bit of daylight at the tip there, which is not bad. That could be milled, clamp this in the mill and take some cuts and true that up. Or even actually tip it back and favor it the other way, because it's going to deflect when you crank on it. So that's kind of cool. So that's how I check that. So, but anyways, that's a lot better than it was. And like I said, now the foot's got air under it, but before it had a belly under the middle. So I think this is about as perfect as we can make it with a 100-year-old piece, and maybe I'll mill that, back mill that, I don't know. So that's kind of fun. Boy, it's a dirty job. I got the gears cleaned and picked every tooth out, and I got a mess in the parts washer with the main body. So we'll keep cleaning and we'll bring it back. Alright guys, I did some tweaking off camera, but you get the process. So let me just show you the after results. I really wanted to home in on this thing. And there is a 9-inch ruler, and you can see how nice that's hitting the whole way. And I have to put it in the back, but you get the idea. Nice and straight to give better, more service when I put it together. All right, I just want to show you how nice I got that tweaked in there. Do the job. All right, guys, we've got the jack ram gear rack here set up in the mill. You can see there's the toe part of the jack, and I wanted to get this actually 90 degrees again, but I want to go a little bit further and tip it back just a smidge. So I got this set up in the vise. This is a 5-inch vise, and I got a 1/16 inch drill bit on the far side there, just raising it up a little bit. So it's a 1/16 over 5 inches angle, whatever that is. And I'm going to be taking off the inside here. So if there is any deflection, it's going to, whatever the object I'm lifting, it's going to want to stay on the jack instead of sliding off the jack. Right now it's angled to slide off the jack just by a smidge. So that's not what we want. So I figured I'd set this up in the mill. And again, I'm using the small closing 8520 mill, the smallest mill I own, because I don't need a bigger mill. I got, you see in my videos, I've got ginormous machines here. But this is kind of a fun, easy mill to use. So let's start whittling on this a little bit and see how it cuts. I got a 1/2 inch end mill, a little bit longer end mill in here. Just for your reference. Let me lock that, 100% make sure this is tight, and it is. Let's see what we can do. Try to keep my head out of it, if I can. Should be soft steel. I mean, reasonably. I don't want to climb. Like this is, let's see, that's conventional. There you go. I can see, you can see. I believe this is cast steel. Now, I'm aware I do not want to leave a sharp radius. I know that. A little bit more. I don't want to go too much. I want to leave the transition radius where it flows out. No stress risers, don't you know? That's climbing it. I'm thinking that's good. I really do. I've got about, I don't know, 3/8 that didn't clean up. Take a little bit more. My mill. Smidge more. Alright, that's getting cleaned up right to the edge. I still got the factory forged cast radius, whatever. Like I said, I think this is cast steel. I really do. That's going to be good. I like that. So, back it away, loosen it up. Ooh. Oh yeah, it's tipped back just a touch. You guys can see that. That's what we milled. I know, it's so hard to show on camera. But like I said, this thing is tipped back just a scotch for the good. And that's going to assure whatever we jack with that toe, it ain't going to come slipping off. So, once again, the smallest mill in the shop continues to pay dividends. Alright guys, I got the jack quite clean and I mocked it up together here with all the parts, most of the parts. Kind of give you a look on the inside. I got the cover propped up with the C-clamp so we can see together. This is the worm shaft that I straightened. And let me go on this side. There's the worm wheels. So this thing was made in Philadelphia, Pennsylvania. I didn't realize that. And it is 4 tons or 8,000 pound capacity. Now, these worm wheels, they're a bit worn. And because the worms were bent, they're worn a bit uneven. Some spots they're actually pretty thick, and some are kind of thin. So I would say they're worn maybe 50%, but there's nothing I can do about that. I think for my usage this will be just fine. And these are steel gears, right? These are cast steel gears, I believe they're cast steel. And they're cast one piece with the spur gears. And the spurs, of course, mesh with the rack on the jack. Or, you know, the spurs, the pinions, whatever you want to call them. And there's a rack on both sides of the lifting ram. The spur gears are worn a bit, the pinion gears, whatever you want to call them. Not too bad, but these are big teeth. So anyhow, oh, and there's my foot. Let me get you a good angle here. And we're sitting, there's the base. And it's canted uphill just a smidgen. You can see where I milled away the serrations and just some are left on the tip. But anyhow, let me kind of show you. And this thing, it tips a little because the cover's not on. And that's how it works. Turns easy. Now this is all dry, no lube. Just an initial assembly. Spins easy. But the neat thing about it is because this is a left hand and a right hand worm, there's no side thrust on this shaft at all, right? And if you push on it, it tips the Right? If I push on this, it tips the jack. So whatever. And this will be guided, you know, when the top is fastened. And see, there's these center holes here. How these shafts are retained is there's little 1/8" pins that drop down, and that hole is drilled in the casting, and there's a hole in the shaft, and it lines up with that center drill. So pins just sit in there, and that's how these shafts are, you know, retained. I don't have them in there now, but I wanted to show you guys how this works. Now, a word about how this got bent, and a word about how the shaft where the worms are got bent between. See, watch this. These two ears, this one's just a little more, are bent up a little bit, like someone was loading the absolute limits of this toe or foot and was trying to tip it. So someone put this into service hard. And when you push down on this, you know, the gears want to rotate together, and I think that put a bend in this worm shaft. So this thing saw some use. Now, I could heat this up cherry red and hammer this more flat, and heat this up and hammer it more flat. I believe this is forged steel, not iron, but I'm not sure. It could be high percentage of scrap steel in the iron. What I think I can do is maybe build up some, it's a flat bottom. You can see this kind of, maybe you can see, up a little bit. I could build that up with braze, heat that up red and lay some braze on the bottom, and then, you know, clamp this surface down on the milling machine and mill it flat. And I think that's less destructive than, well, I don't know. If this is cherry red and I tap on it, it should move. I don't want to break it though. I think building it up with braze might be a smarter, I don't know. But like I said, I just wanted to show you guys how this works with the gears. It's pretty innovative. Like I say, there's no thrust. It's all absorbed within the gearing. That's what makes it cool. I got to put this on. The ratchet guy goes on here. There's the worm side. Pretty cool. This is a 2A Rees jack, patent pending, Rees Manufacturing Company. Pittsburgh, PA, USA. Capacity 4 tons, which is 8,000 pounds. Lift is only 6 inches. Okay. Now this looks like an HD, I think. Now if you look, looks like an HD to me, maybe. Don't know. But anyhow, I'm really happy with the way this came out. When the toe is down all the way, it's just under 2 inches, maybe 1 7/8 inches from the ground. So this is going to be great for lifting up machines or whatever. A 5/8 bar goes in here, this ratchet mechanism, and I got this all. How'd it go? Yeah. Works great. So we'll try that out. Here it is, heavy duty. Pretty neat. Heavily worn. But like I said, good enough for me. I appreciate the intellectual journey down a road to clean up a 100-year-old jack. It's got about 12 pieces to this jack, marvelously manufactured and absolutely well engineered. The engineering just really impresses me. The thought, and it's very simple in, you know, it's cored out, sand cast, really cool. I don't know what it weighs, probably about 20 pounds. But yeah, Rees jack, if you're into machinery, this thing's really cool. Hope you enjoyed watching me resurrect this. And you know, when I do these things, I guess I could say I don't know if I restored it, I cleaned it. I need to put some grease in here, and maybe I'll paint it first, paint it green. But I just love putting my hands on something, and it's almost like I get into the minds of the men that designed this thing, for sure, and it makes me a better engineer for it. So anyways, rambled enough. Hope you enjoyed this Rees jack. Do as a shop.